What's up, people? We are doing implicit differentiation a second time. All right, so I got this whacked out curve here. It looks kind of weird. And first thing they want me to do is find the derivative. All right, so this is my function. And again, because this is dy with respect to x, I know that y is a function of x and x is my variable here. All right. So let's take the derivative of each one term at a time. The derivative of y cubed is 3y squared times dy dx plus 2y times dy dx minus 5 times dy dx, and then minus 2x, and then that equals 0. Alright, so again, I need to factor out dy dx, move everything else across the equal sign. So let's factor out dy dx out of all these y terms. Alright, and I'll move my 2x to the other side of the equal sign. We'll add that. Alright, now I can divide. Right, and so I have my function. Oh, my derivative. This is my derivative. All right, so this is the derivative of this curve right here. All right, now they want me to find the equation of the tangent line. So we've done this, I don't know how many times, it's going to keep coming up. So you got to be comfortable with finding tangent lines. All right, we're going to use point slope formula. All right, so be comfortable with that. So I need to know what my point is. I need to know my slope. Luckily, they gave me the point. And I have a derivative at least, so remember my derivative was 2x over 3y squared plus 2y minus 5. Alright, so let's evaluate my derivative at 1, negative 3. Alright, so I'm plugging 1 in for x and negative 3 in for y. So I got 2 times 1 over 3 times negative 3 squared plus 2 times negative 3 minus 5. Make that look a little better. And so because I'm so smart, I know that the answer is 1/8. Cool, so that's my slope. I got my point, so we're just plugging what we know. So I got y minus negative 3, so plus 3, is equal to 1/8, and then x minus 1. And this is my tangent line. Hooah. Alright, in our next example, they want me to find where my tangent line is vertical. Alright, so we've kind of done the opposite of that with horizontal tangent lines. Okay, that's where our derivative is 0. Now, for a vertical tangent line, there's a couple things that I want. Alright, first of all, I know that I want my derivative to be non-existent. Okay, because remember, if you have a vertical line that's not even a function, okay, so, or you could think of that as an asymptote. Okay, so I want my derivative to not exist. And in order for that to happen, I need to be dividing by 0. Right? So I need the bottom part of my derivative, the denominator, to be 0. Okay, but furthermore, I need my top to not be 0. Okay, so remember, if you're dividing 0 over 0, that's indeterminate form. And that just tells you that something's happening, you need to do something to get the answer, but it's still okay. Okay, but if you're dividing something whole by nothing, okay, that's no good. That's a DNA situation. All right, so remember my derivative was a fraction, if you already forgot what it is. It's 2x over 3y squared plus 2y minus 5. Okay, basically I need the bottom to be 0. So let's set my denominator to be 0. All right, I can factor this. So I got 3y and y, let's see, probably minus 1 plus 5. Okay, so if I solve, I get that y equals 1 and negative 5/3. And remember, these are like points. So if I need to solve for my y, okay, because I want to find the coordinate point. So just giving the y value isn't good enough. I also need to solve for x. And the way that we're going to do that is go way back, way back, and look at this original function that they gave me. All right, that's what I got to plug these y values into. All right, so let's practice by plugging in 1. All right, so my original function that they gave me was y cubed plus y squared minus 5, y minus x squared equals negative 4. All right, so I got to plug in 1. So let's plug 1 in for y. So I get 1 plus 1 minus 5 minus x squared equals negative 4. All right, so this is going to be negative 3. Add that over, negative 1. So that means that x is plus or minus 1. All right, so that actually gives me 2 points here. So that means that 2 of my points are positive 1 comma 1 and negative 1 comma 1. All right, so the y value is 1. My x value is what I solved for over here by plugging into my original equation. Okay, now I just know because I did this, plugging in negative 5/3 gets you a really ugly answer. So you could go ahead and work it out yourself. I would encourage you to practice, but I'm going to go ahead and just give you the answer here. So you end up getting that x equals plus or minus the square root of 849 over 9. And so similar situation, I got to plug these in. So I got the square root of 849 over 9 comma negative 5/3 and negative square root of 849 over 9 comma negative 5/3. Right, so I ended up with 4 points where I have a vertical tangent. And so if I go back up to my original graph here, if you take a look at the curve, that makes sense. All right, so I can tell right here, I'm going to have a vertical tangent, and right here, and then also here and here. And because my graph is symmetrical about the y-axis, it makes sense that my x values would have opposite sign, but my y values would be the same. Right? So just make sure that you have an expectation. Okay, just judging from the shape of my graph, it looked like I was going to have 4 answers, and I ended up with 4 points. Okay, so just be on the lookout for stuff like that, and that's it. I'll see you all later.